Okay, the last video showed you how to enter the data. So at the end of that process, you would end up with some data like this. Okay. So what you're going to do now is to make a pivot table which will crunch these numbers. That's the useful thing about pivot tables. You can take, we only have 100 and, what is this? Let's see what number. 130 something. Yeah, 136 entries, but you could have 10,000. It doesn't really matter. If you want to summarize those, what you're going to do is you highlight the labels for the variables and all of your data. Go to Insert, Pivot Table, let's see, do existing, no, New Sheet. Okay, I'll take you to that. It's a little bit different than the desktop app. Okay, and what we want to do is make a big table that has the traps and the treatment on the rows with a count of how many animals were found at each of those. And again, remember, I did put up a announcement about this, but I am assuming that you're keeping deer and turkey out of this. Okay, so we're looking at all those other animals like the armadillo, the raccoons, the bobcats, the squirrels, the rabbits. These are things that I think could get into the pile that may actually be using the pile for cover. Turkeys and deer, I think there's really no evidence that, based on the literature I've read, that they're going to actually use that pile. So, in the group, it's just going to be those animals that are appropriate. Okay, so we have pile number for rows. Okay, there's your 5 piles, 1, 3, 5, 7, 8. Now we want to break down for each of those pile numbers. We want pile or not pile. So if you take treatment, drag it over here, drop it underneath the rows, you'll see, right, we have pile number 1, the no pile, and the pile, so on and so forth. Play around with this a little bit. You're not going to affect your data. Your data's back over here. It's just, doing its thing. So if you take treatment and drop it on top of pile number, then it's going to arrange it differently. Right? And in fact, this may be, this is probably the better way to do it, considering what the Excel program is going to be looking for when you do your t-test. We may want to do it this way. Then we take group, and you could put group here in the columns, and it will give you a count of all of the bobcats, squirrels, possums, all that stuff for each of these. Right? All you have to do is take group and put it in here. And now it gives you a count of 3 cottontails, the pile number 1, the no pile area, so on and so forth. But I don't think we really, because for your data, you are just looking at the total number of animals observed. So we can take this group out of the columns. Alright, and it just gives you a total count of every time you saw those animals at each of these. Okay, see how easy this is? Very, very easy. Okay, so we're getting real close. Now, what I would recommend that you do is we're going to copy, highlight this whole table, right click, copy, and then you can just go over here and put it on a new sheet, whatever. I just find it simpler to use the same sheet. Right click and then do this one, paste values. Okay, if you just paste regular, it will give you that exact pivot table over here with all the languages and the magic going on underneath. If you just do values, it just pastes the number 15. Remember over here, it's not just number 15, it's all of the code behind the pivot table. Okay, so the way you need this to be organized for your t-test, you don't need these totals. individual or a grand total, what you're going to be looking at is a pile number up here. And then these are the no piles. These are the piles. Just cut these. Or actually, you can just drag them. I'll cut them so it's easier. Put them in there. Don't need this graph anymore. Because again, this 1, 3, 5, 7, and 8 is the same as this up here. Okay, so now what we have is our pairs. Okay, because remember, why did we do paired? Because if you have what we're interested in was what the difference between having a pile and not having a pile. We weren't interested to see how pine forest or fields or high elevation or low elevation, all these different factors that also might affect the number of animals seen there. We wanted to kind of control for those. So for each of the pile cameras, we picked a nearby area with no pile but very similar habitat. So we're really in each of these pairs, we're comparing this number to this number, this one to this one. Okay. So we're going to do t-test equals, okay, and yes. So when you need to use Excel to do some kind of function, right, you could do equals sum. Add up all these numbers. We're not going to be doing this, but just to show you, you can do so much with Excel. If you want average, you can do equals average of those numbers. No, not average deviation. So that is the average of those. Now, I mean, we can do some really cool stuff. So if you just take this same formula, copy it, paste it over here, what it does is now applies it's quite different than the desktop app. If you just do well, equals average here, parentheses. So the average number of wildlife in my fictitious data set, this is not your data set, photographed away from piles was 5 versus 22 at the pile. Okay. The other piece of information that you're going to need, because we know this is differences are partly about the differences in average, but it's also about the difference in variability. Right? So if you do standard deviation of a sample, STDEV, of this sample, this is going to give you an estimate of the variability. Okay, so equals standard deviation dot sample dot s, okay, parentheses, enter. Okay, so 22 plus approximately 10 on either side will give you 95% of your data. You're going to need these numbers for your lab report when you report your mean and standard deviation. Okay, so certainly looks to me like these numbers are different, but well, in fact, we can make, let's make our insert charts. Let's do playing around here. There's a 2. works. It shows each individual pair in comparison of the two. But it's not showing. Maybe we have to do this. Copy this. Put it down here. Well, how do we get it there? So this shows the average of the POW versus the non-POW. But I'll put up another video about how to make graphs. Okay? But suffice to say, this to me looks like it's going to be different. But again, the only way we're going to know whether it's different, and therefore the answer to our question of whether vertebrates are more active at POWs and away from POWs, is to get a p-value. Okay, so we're going to do the same similar approach. We're going to do equals. Now you're telling Excel you're going to be doing some statistics. We do equals t dot test. Okay, and then we do parentheses. Now it's telling you what you're looking for. Inside the parentheses, you're going to put the first array of data, comma, the other array of data. It's always two when you're comparing means of two different groups. You're using a t-test. So array 1, we're going to say from here to here, comma, array 2, from here to here, comma, we're going to do one tail, comma, we're going to do a paired t-test, which is 1. So again, equals t.test, parentheses, first array, comma, second array, comma, number of tails, use one tail, comma, 1 for paired t-test. End with parentheses, and when I push this button, it's going to give us our p-value. Alright, p-value of 0.00018. How do we interpret that number? How do we interpret that number? This tells us, the p-value tells us that we can reject the null hypothesis. We can say that vertebrates use piles or random spots and be wrong less than 0.01% of the time. I.e., in other words, we can be 99.99% confident that rock piles are used by vertebrate animals. Now, really, when I say the inference here is not about all vertebrate animals, because we can only say this for the species that we observe: eastern cottontail rabbit, gray squirrel, bobcat, nine-banded armadillo, and the raccoon. Right. But for those animals, we can say that those piles are working. So if this is our data, right, this data back here, your data is going to be different. If you enter your data, you make a pivot table. Copy that, paste the numbers over here. Do some little bit of rearrangement. Calculate your averages, doing equals average, parentheses, array, right, and parentheses, enter. Calculate your standard deviation of the sample, right, and then you do equals t.test, parentheses, array 1, comma, array 2, comma, one tail, comma, 1 for paired t-test, right, and that pretty much is a bulk of your results. Okay, so one more video, which is how to make a good graph, and you will be ready to rock and roll.